time to get your arrows popping. Ladies and gentlemen, this is Mr. Witt with Fort Bend Tutoring, and today we have a fun and festive tutorial for you today. We have the even and odd functions. We have O'Shea Duke Jackson in the house. What's going on, O'Shea? We have Sandra's in the house. That's right. It's the best way to spend the summer, Sandra. I totally agree with that. And we have Mr. Witt in the house with Fort Bend Tutoring, and I will ask you guys to subscribe to Fort Bend Tutoring. Go ahead and boost up that subscriber list so that we can be motivated to continue to bring you more free and fresh content from Fort Bend Tutoring. Danielle is in the house. What's going on, Danny? That's going on. What's going on? You say I've been taking your tutorials this year. In last live chat, I said I'm afraid I won't pass, but you did. Congratulations, Danielle, on passing. That's what I'm talking about. Let's keep the success going as you have received some help from Fort Bend Tutoring. Danielle says, thank you, Mr. Witt. I've graduated. Well, congratulations on graduating, Danielle. I'm so proud of you. Let's keep that going, and let's keep sharing the love and sharing the math tutorials that we have here at Fort Bend Tutoring. Click on the subscribe button, guys. Click on that bell icon, and let's get things underway. We have the topic even and odd functions today, and here we have our notes for our even functions. And just to let you know, it is a test that is going to be done whether you're looking at the graph of a function or you're looking at the actual equation itself. That will help you identify when you're dealing with even or odd functions. What's going on, Lewis? Always glad to see you in the chat, sir. Always glad to see you. So here we have our even function test right here, and it says that if you are to replace all the x's with negative x, and then when you simplify you end up with the original function, you have an even function. Yeah, that's the test for it. I mean, that's what you need to know. Yeah, and then just to give you some extra cues and clues for identifying even functions. If you have the cosine function and you replace that with negative x, it will be equivalent to cosine of x, verifying that the cosine function itself is an even function. So that means that whether you're in algebra class, whether you're in a pre-calculus class, whether you're in a trigonometry class or calculus class, we're going to go ahead and give you the majority of the tools that you'll need to identify when you have an even or an odd function. And just to let you know, you'll see these types of problems in classes like college algebra, pre-calculus, as I stated before, trigonometry, and calculus courses. All of those type of classes, those pure mathematics classes, will have problems such as this, and you want to be aware of how to solve those type of problems. And that is what we're bringing you today, live. Oh yeah, from the Fort Bend Tutoring Studio. Oh yeah. Okay, so continuing on, if you have a secant function, that is also an even function. And if you're looking at the graph of a function and that graph just happens to be symmetric about the y-axis, that means that that y-axis is the dividing line, is a mirror image on either side of the y-axis, you have y-axis symmetry, and that confirms that you are dealing with an even function. Yeah. Oh yeah. I'm just full of notes today. I'm full of notes today because I have more. I have more because that was just for the even functions. Check out these for the odd functions. So there's an odd function test so that you can do it algebraically. You don't even have to see the graph itself. You can take the equation itself and replace all the x's with negative x, then simplify, and if it's equivalent to the opposite of the original function, you are dealing with an odd function. Lovely Pookie says, can you teach me some 9th grade math next week? Well, lovely Pookie, we'll see. We shall see. But in the meantime, you can check out our intermediate algebra playlist, lovely Pookie, and that has a lot of 9th grade mathematics stuff there for Algebra 1. It sure does. It sure does. And lovely Pookie, don't you forget that there is also in that playlist an Algebra 1 final exam there that you can use to make sure that you're succeeding there. Sandra says, ooh, I'm starting 9th AP in September. Sandra, you're getting way ahead of the ball. Oh my goodness, Sandra. Well, thank you so much for hanging out with us as you build on your foundations. Okay, good stuff, lovely Pookie. Happy to help. Happy to help. And just so that the crowd can know I'm not talking to myself, we have people up here in the chat that is chatting with Mr. Witt as we move forward in this even and odd function tutorial. All right, let's get back to it. So here is, in addition to our odd function test, guys, we have several odd functions. That's right, from trigonometry. These functions here are from trigonometry, guys. So if you don't need these functions for algebra just yet, don't worry. They're coming in your academic careers there, especially for mathematics. And so when you're dealing with a sine function, cosecant function, tangent function, when you have a cotangent function, these are all odd functions. And it's good to have a list such as this so that you can quickly identify just from the equation alone that you may be dealing with an odd function. Yeah, that's right. And if you were to look at the graph, what's going on, Empress Hodge? Good to see you. Good to see you, Empress. Thank you for joining us today. If you were looking at the graph of a function, and that graph is symmetric to the origin, or you can just pretty well say that the right side of the function has been rotated 180 degrees about the origin, you are dealing with an odd function just by looking at the graph. How do you like that? So not only have I given you the odd function test, I've also given you examples of some odd functions from trigonometry. I've also given you a clue as to how to quickly identify an odd function by looking at the graph. We are prepared to start looking at some problems now. That's right. We looked at the even function test. We've looked at the odd function test. We've looked at how to go about identifying the graph of an even function. We have also learned how to go about identifying the graph of an odd function. We are about to partake on the problems that we have. Let's go ahead and take a look real quick at the different type of functions that we'll be looking at today. Here we go. Here we go. I'm just giving you a snippet, see? I'm going to go ahead and give you what you're going to get. That's right. At the beginning of this session here today, we're looking at 12 problems, guys. 12 problems in all. These are the functions that we will be identifying as even, odd, or neither. Okay? As far as identifying the type of functions that we're to be dealing with today. And guys, if you want, you can go ahead and help this process out by donating to Fort Bend Tutoring. Don't forget that at the bottom of your super chat there's a super chat icon, the $ there, that'll help you donate for these live streams and the rest of the free content that we provide from Fort Bend Tutoring on our YouTube channel. So please donate if you're able to, and let's proceed with the problems that we have. You can also find a donation link at the within the description box. There you go. If I can get my words together, right? Let's go ahead and get things cracking with problem number 1, ladies and gentlemen. We have f of x equals to the absolute value of x. F of x equals to the absolute value of x. And the first thing we're going to do, guys, is we're going to see if we can identify whether or not this is an even or an odd function just algebraically, okay? So you see that we have an XY chart here at the bottom that we'll be looking at. You also see that here we have an area for the graph. But the first thing I wanted to show you is that you can identify whether or not this is an even or odd function simply by using the test for even and odd functions. What's going on, Shanette? How you doing? Shanette says, thanks, Mr. Witt. You keep me on point. Well, that's what I have to do for all that I can. What's going on, Sambo? It's good to see. Good to see you there. Let me go ahead and give you a little love, Sambo. There you go. They're the people that we're talking to today, guys. There you go. There you go. Sambo says, you are awesome. Your videos always help me. Well, thank you so much, Sambo, because you're helping me right now. That's right. Lewis is letting us know that the graph of this function will be a V. Let's go ahead and prove Lewis. And we have a donation in the house. Let's go ahead and show the donation some love because we want to help as many people as we can. And when you donate to Fort Bend Tutoring, oh, you better believe that we're going to utilize those monies to help the world with their mathematics. That's right. We don't just take your money and run. Oh, no, there's proof in the pudding because I'm here live with you now because of you and your donations, guys. BGS it more. Thank you so much for your $2 donation. We greatly appreciate that. There you go. Donating to Fort Bend Tutoring is a great way to help us help you guys. So let's get back to this problem here. Thanks again, BGS. You're right here, immortalized in this video right here. We are going to start by using the even and odd test. And how do you go about doing that, guys? First of all, let's find out what f of negative x is. So we want to see what happens when you replace all the x's in the original function with negative x. So notice that I rewrote our original function. I replaced all of the x's in the original function with negative x. The next thing you want to do is to simplify this. And when you simplify the absolute value of negative x, you need to understand, guys, that the absolute value is simply the distance to 0. BGS Idmore says, keep teaching the babies. I'm doing the best I can, BGS. And thank you so much, because you just helped me do just that. You just helped me keep teaching the babies. Thank you so much for your support. I appreciate that. You better believe it. It is greatly appreciated. Every cent, every sacrifice will be put forward in this endeavor. Here we go, guys. So, being as though we were looking at the distance to 0, whether you are coming from the left of 0 or the right of 0, that distance will be the same. And also, since we cannot guarantee whether x is a negative value or a positive value, this will be equivalent to the absolute value of x. Okay, so therefore what we're looking at right now is we're saying that our original function, which is f of x equals to the absolute value of x, is also equivalent to f of negative x. Well, what does that mean? Well, if you were paying attention earlier to our even and odd function test, anytime the original function is identical to the function once you replace the value of x with negative x, that means you're dealing with an even function. That means you are dealing with the even function. But also know this, the functions that you deal with can be both even and odd depending on the problem, you see. So therefore, depending on the test that you're doing, and I'm probably blurring the lines right here, guys. So it's going to be either one or the other. Okay, so what I was doing was I was mixing up the symmetry rules and they're real quick. So let me clarify. You're either going to get an even function, an odd function, or neither. It will not be both, okay? It won't be both. So let's take a look at that odd function test, by the way. The odd function test says that if you have the opposite of the original function, if it's equivalent to the substitution of x with negative x, then you're dealing with an even function. So right now, we already know that this is an even function because the original function is equivalent to the substitution of x with negative x. All right. So in other words, us simplifying the value of f of negative x is equivalent to the original function. Therefore, we're dealing with an even function. Matter of fact, I'm going to go ahead and put this in a red box, ladies and gentlemen. So we are dealing with an even function right now. But just to let you know what that process looks like when you're dealing with an odd function test, then simply change the sign on the terms in the original problem and see if that is equivalent to your substitution of f of negative x here. And it's not. In other words, the absolute value of x does not equal to the opposite of the absolute value of x. Therefore, this is not an odd function. It's an even function. And that's the bottom line to this problem right here. Yeah, and that's doing it algebraically. But check this out. You could have also identified this by looking at an XY chart. So notice that I have values here about the vertex of this graph. All right. And notice that if I plug in the opposite value of x, let's say that x is 1, and I plug in the opposite value of that x, which would be -1, right? I still end up with the same value of y. My f of x value, in other words, the y variable, ends up giving you the same result. So just looking at your table here, you can identify this as an even function because when you replace any value of x with its opposite, you end up with the same output. Whether your input is negative or positive, the output is the same value. That is also a way to tell whether or not you're dealing with an even function. And then let's go ahead and look at the graph. Let's do that. Let's go ahead and change my ink to black. All right, because that's where it's at. We have 0, 0. That's the origin. You have -1, 1. Oh, yes. The graph is underway. We have -2, 2. I know you know how to plot points, right? There you go. You start at the origin. You move to the left and right according to the first value, the x value. You move up and down according to the y value. There you go. And let's go ahead and put this in red. Let's see what this looks like here. Oh, we're going to put arrows on both ends. Look at that V shape, Lewis. There you go. There you go. And notice how we have identified that this graph is symmetric, okay, with the y-axis. That the y-axis itself is a mirror to the left and right sides of this graph. This is a graphical way to identify an even function. Anytime your graph has symmetry, y-axis symmetry right here, that the y-axis splits your graph in two equal parts, you are dealing with an even function. So not only, guys, have I shown you how to identify the even function by using the algebraic test, the even and odd test there algebraically, we also looked at the table of our points to identify that it's an even function. We also looked at the graph and we identified that even function that way. And we are moving on to our next example, ladies and gentlemen, as I change the ink to black, because that's where it's at. Problem number 2. We have f of x equals to x cubed, guys. F of x equals to x cubed. And we wanted to identify whether or not we are dealing with an even or odd function. And guys, just to let you guys know, we have Alexander Stevens in the house with a donation. Thank you so much, Alexander, for your $5 donation. That is where it is at. Thank you so much for helping out Fort Bend Tutoring reach the world, aka SBGS. Idmore said, teach the babies. So we have Alexander Stevens with a donation. Thank you so much, Alexander. Much love to you. Much love to you. Let's get back to the algebraic test to identify whether or not this is an even or odd function. All right, Lewis is letting everybody know that this is going to be the snake chart. This is how he identifies the graph of the cubic function that we're dealing with right now. Our f of x equals x cubed is the parent function for a cubic graph. Let's check it out, guys. We can do the test by replacing every x with negative x. Let's see how that works. Replacing that x with negative x, we're going to go ahead and make sure that's in parentheses to show that the value of x itself has been replaced with negative x, and then you're going to cube it. So this literally means negative x times negative x times negative x. That result, guys, will end up giving you a negative x cubed as the answer. Now, is this value identical to our original function? It's not. Notice that it's the opposite of the original function. In fact, if we continue with our algebraic test, if you were to find the opposite of the original function, it would be identical to when we replaced x with negative x. So notice, and we'll put this in a purple circle here. There we go. That in between step we want to identify. We notice that when we replace all the x's with negative x, you end up with negative x cubed as a result. However, that's identical. It's the same as when we find the opposite of the original function. That also gives you a result of negative x cubed. This similarity here, or this congruency here, you might as well say, verifies that you are dealing with an odd function, guys, and you of course need to red box that answer. Put your answer in a red box. Go ahead and protect yourself from the evils in the world with a red box around your answer. It helps your teacher identify that much more. Amen, amen. All right, look at Tony. Tony is already in his house, and that's probably Noah as well, identifying. I see you, Noah. I knew it was you. So Noah is also identifying that our function here is an odd function. Well, how do you tell that when you're looking at the table? All right. Now, Alex says, what's the max and min, Mr. Witt? Well, the max and min can be identified by using several tests, some in algebra, some in calculus. And it's called finding relative extrema. And it's also called finding the absolute max and min. And we will not necessarily be focusing on that today, Alex. But you know what? Since you made a donation, let me go ahead and show you this. It's easier to identify in a problem like this, Alex, because you are a donator. Let's go ahead and answer that question real quick. In a problem like this, where we have the absolute value, it's quick to identify what the max and min of the function will be, because in this particular problem, you actually have some boundaries here. You can't get any lower than 0 on the y-axis there. Okay, so the lowest value there is at 0 on the y-axis. Therefore, this has a minimum because it bottoms out. You see? So it goes into positive infinity, all right, in either direction there. But as far as the y-axis is concerned, it goes to positive infinity, the graph does. However, it stops at 0. So therefore, you would say that this graph has a minimum and it's unbounded as you go up because it goes to positive infinity. So in this problem, we have a minimum value of 0. Okay, so that's what you can identify in this problem. However, let's check out what happens in this graph, okay? And so that's what we can do for this problem here. Good stuff, Noah. All right, thanks for helping out in the chat. Let's go ahead and look at this graph here. Well, first of all, the table, you can see that if you plug in the opposite value of any x value, you'll end up with the opposite result, right? So this is another way to prove that you have an odd function. Remember, the test says that when you plug in the opposite value of x, that should be equivalent to you changing the sign on that original y value itself. So when I plug in the opposite value of an x value that I plugged in, I'll end up with the opposite y value. So this confirms that I'm dealing with an odd function. Once again, if I compare a positive 2 with the opposite of that, in other words, a negative 2, I end up with the opposite value of y. When we plug in positive 2, you end up with a positive 8. But when you plug in the opposite of that value, the opposite of that is negative 2, you end up with the opposite result. This relationship confirms that you are dealing with an odd function. So that is one way to identify whether or not you're dealing with an odd function, just by looking at the table. All right, but for Alex's sake, let's go ahead and graph this. Let's see what this graph looks like, because he was requesting what would the max and min be for this particular problem. So let's see. Let's go ahead and identify some points here. We have the origin, of course. We have negative 1, negative 1, negative 1. All right, we have 1, 1. We also have 2, 8, which would be here. We have negative 2, negative 8, which will be here. So as Lewis was saying earlier, you end up with a snake-like graph. All right. And so you don't have a max or min in this necessarily because it goes to negative infinity and it goes to positive infinity. In other words, it's unbounded. All right. So there are times that you can have a graph similar to this where it has peaks and valleys, and then you can say that you can have something like a local min or a local max. But overall, this is unbounded as it goes to positive infinity and negative infinity. So you wouldn't necessarily have a max or min in this particular problem, Alex. All right, good stuff. All right, so Alex says, yeah, I get it, Tony. A little tricky, but I got it. Good stuff. Thanks for asking, and of course for your generous donation, Alex. I appreciate you being in the chat and being a constant watcher of Forbidden Tutoring's videos. Let's keep it going, guys. That was problem number 2, as we identified the function f of x equals x cubed as an odd function. Noah says, I love graphing. Well, good stuff, Noah. Good stuff. I'm sure the graphing loves you right back. Let's look at problem number 3, guys. Problem number 3, we have the following. We have f of x equals to the opposite of x squared, negative x squared, plus 4. And we want to see algebraically first whether or not this is an even function, an odd function, or neither. Okay, it could be neither an odd function or an even function. We don't know. Let's figure it out. Let's first of all start our algebraic even and odd test by replacing all the x's in the original function with negative x. Let's do that first. So it'll look like this. We'll have the opposite of negative x squared plus 4. Simplifying this, we have negative x squared, which means negative x times negative x, and negative x times negative x is x squared, but then you have the opposite of that, so you'll end up with negative x squared plus 4. Well, that expression looks familiar, doesn't it? I mean, doesn't that just looks like the original problem that we have here? So if it's identical, when you replace your x's with negative x, if that result is identical after you simplify to the original function, you are dealing with an even function. Very good, Sandra. Sandra's in the house with her answer there. We have an even function here, guys. That's exactly what we have. We're going to put this in a red box for Sandra. There you go. Sandra, you're on fire. Let's go ahead and prove it to the world. Sandra has her answer, guys. She is playing no games here. She has a result. There you go. Let's keep it going. Let us keep it going. We have a donation from Tony Scovos, a.k.a. Noah. All right. Appreciate your donation, Noah. So we got Noah in the house with a donation. Appreciate that going, guys. You guys are doing awesome today with the donations. I really, really appreciate that, as that motivates me to get online with you guys and get it going. Lewis says that the answer is going to be, aka the graph is going to be a sad parabola. Let's see what he's talking about. And you know what? I just wanted to confirm that we know that we have an even function by taking our even and odd test a step further and going ahead and showing the result of the opposite of f of x, just so everybody can have that in hand. Remember that when you're finding the opposite of the original function, all you do is change the signs on each term in the original equation. So therefore, this will be x squared minus 4, and notice how this is not identical to the substitution of x with negative x. Therefore, we can't say that it's an odd function. It's definitely an even function. All right. Well, what happens with our table here? So notice our table, we're going to be focused and centered around the vertex of this graph. So starting at 0, 4, and then fanning out from there to the left and right on the x-axis. If I were to plug in positive 1, I get a result of 3, right? However, if I change the sign on that 1 and make it negative 1, and I plug it into our original function, I end up with a result of positive 3. Well, what does that mean? That means that it doesn't matter what sign the value of x is. Okay, the answer will still be the same. That means that we are dealing with an even function, ladies and gentlemen. We're dealing with an even function, and you can tell that, you can identify that just based on this table, even without doing the algebraic test at the beginning. If you have a table before you and you have additive inverses, aka opposites of those values, of course, and you're centered around the and you're centered about the origin, or is centered about the y-axis, you can show that we have a mirror image here about the y-axis, aka you have y-symmetry, aka you're dealing with an even function. Okay, and you can tell that just based on the table. I mean, let's go ahead and just graph this out so I can show it to you visually. I mean, I'm not scared here. I mean, just a little, but you know, I'm gonna get over that fear. Let's go ahead and graph this out. I think I like the red points like I did last time. Let's check that out. Let's check that out. So let's say that we had 0, 4. That's our first point. That's the vertex. Okay. And in this case, Alex, this would be a maximum for this graph. All right. So just to piggyback on that question you asked earlier, it's easy to identify the max and min when you actually graph it. That's the easiest way, Tony. Alex. However, there are also ways to identify that min and max when you are dealing with calculus methods, dealing with local and absolute extrema. There you go. All right. So you're not stuck with that. So let's look at this this graph here. We have the 0, 4. We had negative 2, 0. There we go. We had the negative 1, 3. Okay, that would be here. We have 1, 3. That goes there. We have 2, 0. That goes there. All right, and then this is going to be a U shape, a sad parabola, as Tony pointed out earlier. Okay, so there we go. There we go. So notice we have that sad parabola that Lewis was referring to. Okay, notice that it goes down, that we do have a max in this case, and the max of this graph here, Alex, is going to be 4. The max is the y value. It's going to be 4. So look at Alex making me do extra work in this video here. I see how you doing. I see your angle here, Alex. It's working though. It's working. You're definitely giving the people more information than they would have received, which is part of the benefit of you guys participating with me. You're able to pull out more information out of me when you are engaged and active in the chat. That's right. So we have y-symmetry here, guys. You know it's y-symmetry. Why do I know this? Because the left side of the graph is a mirror image to the right side of the graph. This is y-symmetry, guys. If you have y-symmetry in your graph, it is guaranteed that you are dealing with an even function. There you go. 3 ways to identify that this particular function is an even function. You can tell graphically, you can tell by the table, you can tell by the even and odd test that you can conduct by replacing all the x's in the original problem with negative x, and also by finding the opposite of the function that you were given. Amen, amen. Oh, it's a good day today. It's a good day to learn something today, isn't it though? Let's look at problem number 4, guys. Let us look at problem number 4. Here we have f of x equals to the square root of x. This is a square root function, guys. This is a square root function. And you know what? Let's go ahead and cheat a little bit. Let's skip to the table first. And what is this table telling us? This table is telling us that if you attempt to plug in -9 into this original function here, the function, of course, once again, is the square root of x. The function is the square root of x. The function is the square root of x. Thank you. That if you try to plug this in, taking the square root of -9 does not generate a real number. So as far as the real number set is concerned, this is undefined. You can't take the square root of -9 and get a real number. Okay, so if you try to plug in -4, what happens? You once again, it's undefined. It's not a real number. If you plug in -1, it's not a real number. However, if you plug in 0, you get 0. If you get 1, you get 1. If you plug in 4, you get 2. If you plug in 9, you get 3. Let's go ahead and graph this and see what we're dealing with here. Let's go ahead and graph it. Let's see what happens. We can't plug in any negative values. That's clear, right? But we can start by plugging in values that are positive and 0. So 0 works. You know, you plug in 0, you get 0. Plug in 1, you get 1. Okay, you plug in 4, you get 2. You plug in 9, you get 3. And if I were to go ahead and graph this, here we go. You end up with a function that looks like that. Now that's ugly, so we're gonna fix it. We're gonna see if we can make this look better. Okay, this looks a little better, so we're gonna keep this version. There we go. We're gonna keep that version right there. So Lewis says that this graph is a rocket chart to the right, is the way he describes it. And bottom line, guys, is that this is the entirety of our graph here. And notice that we do not have symmetry about the x-axis. Excuse me, about the y-axis. There's no symmetry. We don't have a mirror image to this right side on the left side, do we? We don't. That's right, Alex. Amen. And Alex, by the way, we do have a minimum value on this, Alex, and the minimum value is 0. See, you have a bottom on this. So therefore, that minimum value is 0 as far as that's concerned. Once again, pulling out more information out of me, Alex, with your participation and especially your donation motivates me to give you more. Then, as we're looking at this, we don't have a rotation of 180 degrees on the left side here, do we? No, we don't. All we have is this rocket, as Lewis would say, on the right side of the graph. So you're right, Sandra. This would be neither. It's neither odd, nor is it even. It is neither one of those. So the answer here is neither. So they will give you the 3 options of whether the function will be even, odd, or neither. And Sandra, you're correct. This answer is neither. Sandra, we're putting this in a red box for you because you were the first one with the correct answer. But let's say right now, Sandra, that we attempted to use the even and odd test. Let's see what happens on that. Well, if we had f of -x equivalent to the square root of -x, then that would tell us off the bat that one of these values is not going to work here. Okay, that this is not going to be, it's not going to work. One of these is not going to fly depending on the value of x. One of these would be undefined because the domain of a square root function, guys, is 0 to positive infinity. Yeah, it's from 0 to positive infinity there. So it can't be it can't be the same. In other words, bottom line is this value is not equivalent to that value there. So it's definitely not. It's definitely not. Thank you, Noah. You take care. Take care and be safe on your flying lesson. You are an adventurous person, Noah, and I also appreciate your donation. Good job, Noah. You take care. Have fun and be safe. All right, so what we're looking at now is the algebraic even and odd test for this particular function for number 4. So we started out with f of x equals to the square root of x. If you substituted in that x with negative x, you would end up with a different value. This is not the same value here, okay? Also, if we went ahead and looked for the opposite of the original function to see if that would be equivalent to our substitution of x with negative x, it is also a different value. This is the opposite of the square root of x. So not only do you have to contend with whether or not any of these values are actually going to be real or undefined as far as the results are concerned, these are not equivalent to one another. None of these options are congruent. Therefore, the result must be neither. So whether you had the graph, the table, or you did your even or odd test on this function, you could identify that this result is neither odd nor is it even. Amen. Amen. Yeah. And that's the first 4 problems, guys. That is the first 4 problems. How you like that? So I wanted to remind you that that's right, you can set up a paid online tutorial today with me and FBT at tutormemath.net. So just wanted to remind you guys that we do one-on-one tutorials online using FaceTime preferably, but we can also hook up you Skype users, you know what I'm saying? If you don't have an Apple device, and why wouldn't you have an Apple device? Because it's so easy. I mean, you know what I'm saying? It's just easy to connect and all. But that's okay. I'm not working for Apple, nor are they sponsoring this. Hint, hint. Bonita Applebum is in the house, says, hello, Mr. Witt. I am so glad I caught you this Saturday. Interesting, because it's Friday where I am right now, and I am glad that you caught me today. Absolutely. Are you in the Philippines, Bonita Applebaum? Where are you at? You're somewhere where it is the next day. That is exciting. All right, we are now looking at problem number 5, guys. We are now looking at number 5. And for number 5, we have f of x equals to x times sine of x. Yeah, absolutely. And Sandra says, that's right. That's Saturday. Oh, yeah, there you go. So it depends on where they are in the world. They could possibly be already in Saturday. Interesting, right? So here we're looking at problem number 5, guys. And Lydia is in the house laughing out loud. Let's go ahead and throw this chat up over here. There you go. All right. So Bonita Applebum says she's in Cali. She's in Cali right now. He's in Cali right now. I work nights and got my days mixed up. Haha, I'm in Cali. That's all right then. So y'all doing good out there in Cali where you got your days all mixed up because you're working too long. You're working way too long. Oh, Sandra says she thought that she was talking about the SAT test. No, they was talking about the day, Sandra. She thought that the day was Saturday. Ain't that crazy? Today's Friday. Let's keep it moving, guys. Let's keep it moving. So here, to do the test on this problem right here, we need to know that if you substitute in the value of negative x here, what would happen? We have negative x, replacing that x with negative x, and then we'll be also finding out the sine of negative x. And if you recall from the previous problem, from the notes at the beginning, we were stating that the sine function itself is an odd function. The sine function itself is an odd function. Alex says, let's go ahead and hit that like button, guys. I appreciate that support, Alex. Go ahead, guys. If you don't mind, go ahead and please like the video. Of course, share the video. Share this stream on your Facebook, on your Snapchat, wherever you can. On your Pinterest, go ahead and post the stream here so that everybody can get a little bit of the FBT love. Absolutely sharing our knowledge with the world for free, especially when you help us along the way, as Alex has done today. He's put his money where his mouth is, and we appreciate that. It's good seeing Alex with money in his mouth. It's a good look for Alex. All right. So here, guys, let's go ahead and simplify this further. We are told earlier that when you have sine of negative x, it's equivalent to having the opposite of sine of x. Yeah, we showed that at the beginning, that this being an odd function, that when you replace x with negative x, is equivalent to having the opposite of sine of x. Yeah, and now because we are using our integer rules here, we know that a negative times a negative is a positive, right? Well, this is going to be equivalent to x sine of x. Well, isn't that something? Well, isn't this identical to our original function, guys? Is that not the same value? Is that not the same exact equation that we started out with? Well, it is. So that means that if you replace your x's with negative x and you end up with the same result as your original equation, that means that you're dealing with an even function, guys. This is an even function. That's exactly right, Sandra. Good job. Let's go ahead and put a red box around the answer. And you know what? Let's go a step further here. Let's go a step further and make it a red rectangular prism. Oh yeah, we put our answer in 3D. There we go, just like that. That's problem number 5. And for those that wanted to know what would happen if we continued that test and found out the value of the opposite of f of x, well, then that result will simply had been a negative x sine of x, which does not match the substitution of x with negative x. Therefore, we cannot confirm that this is an odd function. Instead, we confirm that it's an even function because our substitution led to an equivalent result that matches our original equation. That's right, Benita Applebum. I am fancy, and don't you forget it. That's right. Oh, I'm getting fancy, all right. Let's go ahead and immortalize that statement right there because it was cute. That's right. Benita Applebum 72 says, oh, you getting fancy, Mr. Witt. All day, day. And don't you forget it. So here we are moving on, ladies and gentlemen. That was problem number 5 with our even and odd test. The chart is like an exponential. I bet it is, Lewis. I bet it is. The chart is like an exponential. But is it symmetric on either side of the equal sign? It should be, right? So as long as it has y symmetry, Lewis, we should be able to confirm that graph is an even function. All right, because it passed our test. So I'm interested in seeing what that graph will look like. That you're saying that it looks like an exponential. All right, but you said it's only on the first quadrant only. Interesting. Okay. All right. Well, according to the test, though, it should still come out to be even. I'm going to have to take a look at that, guys. So keep me honest on that, guys, and keep me focused on the chat. Make sure that function is an even function. I am to understand that would be an even function based on the test. And the graph should also show that, okay? But if it doesn't, let me know, all right? And I'll make a correction. Let's go ahead with problem number 6, guys. With problem number 6, we have f of x equals to sine of x plus cosine of x. We have sine of x which plus cosine of x, and we wanted to determine whether this function is an even or odd function. Let's go ahead and do our algebraic test on this particular problem by replacing all the x's with negative x first. Let's check that out. So what happens here is we have sine of negative x plus cosine of negative x. We'll recall that the sine function is an odd function by itself. So this is equivalent to the opposite of sine of x. Now, that's just ugly, right? So I'm trying to fix my n. There you go. So this is equivalent to the opposite of sine of x. And then, because the cosine function by itself is an even function, that when you replace the cosine of x with negative x, then you end up with cosine of x. All right? So this is the result of our substitution of the original function with negative x instead of x. Now let's see what happens when we find the opposite of f of x. Now remember, in this situation, all you have to do is change the signs on both sides of the equal sign. All right, good stuff. So you're referring to the sine wave. Yeah, I know that the sine wave is what it is, but we were talking about if you have x sine x in that previous problem. All right. Sandra says, sorry, I didn't finish. No problem, no problem. Let's go ahead and continue, guys. So we're changing the signs on each of the terms of the original problem. You'll have the opposite of sine of x. That looks good so far. However, that second term will also become a negative value. So you end up with negative sine x minus cosine of x when you're finding the opposite of the original function. Now notice, none of these values are congruent with one another. So if the f of negative x doesn't equal to f of x, and if the opposite of f of x doesn't equal to f of negative x, then the result of this problem is neither. So the answer is neither, because what we were doing is we were comparing this result, and this result. Okay, the original problem, of course. So if your original function matches your substitution of x with negative x, that means that you have an even function. If that substitution is equivalent to the opposite of f of x, then that means you have an odd function. And if neither one of those situations occur, as in this case, the answer is neither. Sandra says she gets it. That is awesome, Sandra. I'm glad you are getting it. And that is the result for problem number 6. Pick up the sticks and let's move on to our next problem right here. We have problem number 7. Problem number 7 is a linear equation, guys. We have a linear equation. This is in the form of y equals mx plus b. You might as well say that you're looking at slope-intercept form right here, right? So we're all familiar with slope-intercept form, aren't we? That y equals mx plus b. You're familiar with that, right? Slope-intercept form. It's a line. It's a line. It's just a line. And what we'll do is we'll see if this particular line, okay, what you can see, Sandra. Okay, there you go. So let's see. So Lydia says, so if f of negative x is even and the opposite of negative x is odd. Right. That's only if they match that f of negative x there, Lydia. So what you'll do is, let's just say in general, you're looking at the original function is f of x. You'll then plug in f of negative x, and you're plugging in the opposite, and then you're seeing what the opposite of f of x is. So if these two match, you're dealing with an even function. However, if these two match, you're dealing with an odd function. So that's what we're looking at, Lydia. So you're saying that if the original function and f of negative x, if they match one another, you have an even function. If f of negative x and the opposite of f of x, if they match, you're dealing with an odd function. And if neither one of those situations is occurring in your problem, then it's neither. Okay, so hopefully that clarifies it right there. That's what you should be dealing with. All right, good deal, good deal. All right, Sandra, I'm not sure why you can't see it. Go ahead and close out your browser there, and then go ahead and log back in, and then see if you can see it. All right, because I think everybody else is okay unless somebody else is having technical difficulties. But as of right now, I'm thinking that everything should be visible to you. Okay. All right, so don't scare me like that, because I'm trying to stream to the people here. So don't tell me that nobody can see it. You're scaring me. All right, so Sandra says, okay, she'll be right back. Ladies and gentlemen, go ahead and let me know if you can see the screen okay, if you can see the screen, if you can see it, and also if you can hear me, all right? Just to be sure that everybody is getting a good stream and can see. All right, so Beating Apple Bump says that she can see it. Good deal. So Sandra, you must be having some technical difficulties. Go ahead and iron that out and come right back in. All right, so here on problem number 7, let's go ahead and go with this even and odd test on this linear function here. Thank you, Lewis. We'll have f of negative x. We'll end up with 3 times negative x plus 4. When you simplify this, guys, you'll end up with negative 3x plus 4, and this is the simplification of going ahead and plugging it in. All right, lovely. Pookie says I can see in here. Good. Lydia says I can see in here. Thank you. Sandra says okay, I'm back. It works now. Fantastic, Sandra. I'm glad you can go ahead and join in the stream again. Thank you so much. So now what we've done thus far is we've taken our original function of 3x plus 4, which is a linear equation. Once again, it's in the slope-intercept form, by the way, which is y equals mx plus b. We're doing the even and odd test on it by replacing all the x's in the original function with negative x, simplifying, getting negative 3x plus 4, and now we're going to see what happens when you find the opposite of f of x. Remember, we were talking with Lydia earlier, and we were stating that if your original function matches your substitution of x with negative x, then you're dealing with an even function. However, if your f of negative x is equivalent to the opposite of f of x, you're dealing with an odd function. So that's the whole even and odd test in a nutshell there. Okay, there you have it. So let's see what happens with this opposite of the original function. All you need to do is change the signs on every term in the function. That's how you can tell. And Sandra says we're dealing with a neither situation, that it's neither odd, nor is it even, because when you're looking at the value of f of x, when you look at the value of f of negative x, when you look at the opposite of f of x, these do not match up. Okay, so therefore, as Sandra states, it is neither. Exactly. So don't go into these problems assuming, especially if you're new to the graph, especially if you're new to the function and don't have a visual representation in your mind of what this graph will look like. If you're unable to do that just yet, then you need to go ahead and carry out the process for the even and odd functions to verify whether or not you're dealing with an even or odd function. Go ahead, in other words, prove your result. Prove your answer. If you were to just tell me outright that this was going to be neither odd nor even, how am I to take your word for it? Go ahead and prove it to me by showing me this even and odd test and proving to me why the function is neither even nor odd. Okay, so we're going to prove ourselves, prove our worth, prove it with work and steps to show that we are dealing with either the even, odd, or neither as far as the functions are concerned. This is the answer, guys, to problem number 7. And you better believe that Sandra had her answer right again. Y'all better be keeping up with Sandra, because Sandra's playing no games today. She is playing no games today. Let's go ahead and record Sandra's results here so everybody can see that she has neither at the bottom there, confirming her results, because Sandra is on fire, guys. She is on fire. Good job, Sandra. Let's look at problem number 8, guys. Problem number 8 is in the house. We have f of x equals x squared plus x minus 3. Once again, guys, in the first 4 problems, I wanted to give you a snippet of how you can attack these functions to identify whether they're even, odd, or neither by using the even and odd test, by using a table, by graphing the equation. But the rest of the focus here, guys, obviously, is going to be using that test algebraically. I would love for you guys to be able to quickly do this by hand to identify what these functions will or will not be. All right, because a lot of times it's a time saver. All right, so it's not much work really to go ahead and slap in a negative x for the x, right? That's not hurting anybody. That's not hurting you. And now we are going to continue with this process here. We have replacement of x with negative x. We have negative x squared plus negative x minus 3. This is what we have thus far, right? And we know that when we simplify this, all right, good stuff, Alex. Thank you for letting me know that you can hear and see me as well. That we have negative x squared, which means negative x times negative x. That simplifies to give us x squared. We know that when we have the opposite of x, when you combine these signs here, that's just negative x. And you'll bring down the negative 3 here. Amen, amen. Okay. Then, moving forward, we'll be looking at the opposite of f of x. That's what we have next. And when you have the opposite of f of x, we are going to find out the opposites of each of the terms here. That gives us negative x squared minus x plus 3. That's what we have there. So the question is, does our f of negative x, does that equal to our original function? No, it doesn't. That doesn't match our original function. Well, does this f of negative x, does that match the opposite of the function? No, it doesn't. So it's not even, it's not odd, it's going to be neither. It's neither. Once again, proving that you are not to assume the results, guys. Don't assume what the answer will be. Okay? Do yourself a favor and carry out the process. Okay? Do yourself a favor, carry out the process, take your time, do not make any assumptions, follow the steps to prove your result. That's what I want you to do. Take your time with it. In other words, don't make an easy problem hard by making assumptions. Don't do that. The process is there for a reason, and it doesn't take that long. All right. So even though we knew that the graph of this was a parabola, that's great. And in previous problems, our parabolas turned out to be even functions. That doesn't mean that all of the functions that are quadratic will be even. You see where I'm going with that? Okay, so that means it depends on the equation. So you have to take each equation, all right, and work out the process to identify whether or not you're dealing with an even, odd, or neither as far as the functions are classified. All right, so take your time with that, guys. That was problem number 8, and number 8 was neither. Okay, and just to let you guys know, I'm going into this blind today. I didn't check to see if these functions prior to this recording was going to be even, odd, or neither. So I'm finding out with you guys what the results will be. Okay, I put together these problems, but I didn't check to see if they were going to be even, odd, or neither. All right, so I'm finding out with you guys. Okay, so just to let you know, so I'm going in with no assumptions, and you shouldn't either. All right, there we go. So we have problem number 9. Problem number 9 is in the house. Lewis is in the house. Sandra's in the house. Lydia is in the house. Alex is in the house. Lovely Pookie is in the house. And we're going to do number 9. Okay? And if you're in the house, you need to let me know. So we have f of x equals x divided by x to the 4th power plus x squared. What do you guys think this will be? You see where I'm going with that? Are you certain that you know the result of this just by looking at it? Well, let's see what happens. If you go ahead and replace all the x's with negative x, let's see what happens here. You'll end up with negative x in the numerator. In the denominator, you'll have negative x raised to the 4th power. Okay, that's supposed to be a 4. Let's fix that 4. That was an ugly 4. This is a better 4. This 4 is better. It's not as good as yours. Bonita Applebum is in the house. That's right. Thank you, Bonita Applebum. Can't forget you. Cannot forget Bonita Applebum. You got to put me on. Exactly. That's Tribe Called Quest, y'all. Abstract in the house. That's right. The 5-footer. Rest in peace. That's right. Let's go ahead and go forward here. We got f of negative x replaced in the function. Let's go ahead and simplify this. Simplifying this, ladies and gentlemen, you'll end up with negative x divided by. Now, because we have a negative base raised to an even exponent, guys, you better believe the result of that will be positive x to the 4th power. In the denominator, the second term, if you have a negative base raised once again to an even exponent, the result will be positive x squared. There you go. There you go. So overall, we can say that this was the opposite of our original function. So you can just pull out that negative there. Okay, so you could have it in the numerator, you can distribute that negative in the denominator, or you can just pull it out front as I did right here to show that this is the opposite of the original function that we started out with. That's exactly what we can do. And now let's see what happens when we go ahead and find out what the opposite of the original function is. So I'm going to find out what the opposite of f of x is now by simply changing the sign on the original term. Well, because this was a monomial to begin with. I mean, we just have one rational expression right here. Do you not agree? Well, then the only thing you need to do here is just change the sign on it. What you waiting for? Go ahead and change that sign on that problem and stop playing around. What is wrong with you? Go ahead and slap a negative sign in front and you'll be done. Okay? You know what I'm saying? Now, let's do some comparisons here. Lydia says, this makes a lot more sense now. Thank you so much, Lydia. I'm doing my best to explain this concept. Your confirmation warms my heart, Lydia. My heart is warm here. When you're a human being, you want to have a warm heart. Cold hearts don't go very far. Not at all. So, here's the deal. Looking at our original function, f of x, we had x divided by x to the 4th power plus x squared. That's our original function. We slapped a negative x in there, simplified it, and found that this gave us the opposite of the original function. Yes, it did. Then we found out the opposite of the original function f of x. We slapped a negative sign in front because that's all we had to do. And plus, it's lazy. I'm just saying, it's just, can we not be lazy and get the right answer? Thank you. And notice that f of negative x is equivalent to the opposite of f of x. What does this mean as far as having an even, odd, or neither function? What does that mean? What does it mean? Do you remember? I remember. It means that the result is neither. That's what it means. No, not neither. It means it's odd. What's wrong with me? This is an odd function, guys. Sorry. Got carried away. It's an odd function. All right. Silly rabbit. So here we go. Yeah, so when we plugged in our negative x there we go. We ended up with the opposite of the original function. There we go. And it matches having the opposite of that function. That's right. So therefore, because our f of negative x and the opposite of f of x is equivalent, we are dealing with an odd function. Sandra is cosigning the odd function. There you go. Sandra says, yeah, I was confused for a sec. I confused myself, Sandra. I confused myself. Just as Lydia was giving me props for clarifying things for her, I went ahead and jacked it up and confused myself. So there we go. So the bottom line is, guys, that we had f of negative x being equivalent to the opposite of f of x, and that confirms that we are dealing with an odd function. There we go. It's in a red box. Okay? Once you put it in the red box, it's good to go. All right? I try my best not to put a wrong answer in a red box. That is the correct answer. It's in a red box. I used the red box to put the right answer in. All right, let's move on. Lydia is having fun with me today. Yes, she is. All right, we have problem number 10. That's right, problem number 10. This is a rational function. Yeah, that's what it is. Yeah, let's see what happens with this. We have f of x equals to 7 divided by x. That's what we have. Yeah. And you and I, I feel you. I'm with you right now. We are going to use the even and odd test to determine whether or not this is going to be an even function, an odd function, or neither. That's what we're going to do. See? You see? That's what we're going to do together. We're going to find out what f of negative x is first. So if I replace this x in the denominator with negative x, we could actually just go ahead and just pull out that negative in front and show that it's the opposite of the original function. Yeah. Lewis is confirming that the previous problem. Oh, no. You guys are going ahead and telling me that this function is odd. Let's see. Let's see, guys. Let's see. Lydia is saying, yeah, it's odd. Yeah. Lydia with the cosine. Lewis with the odd in all caps. Sandra with the odd. There we go. Let me go ahead and see what this opposite of f of x looks like. If I take the original function and I just put a negative sign in front, it looks as though we have congruency with f of negative x. That's what's going on. It is the same value as the opposite of the original function, which is also negative 7 over x. And if f of negative x is equivalent to the opposite of f of x, you're dealing with an odd function. Let's go ahead and recap over that summation of the rules again. Let's go ahead and recap, shall we? Let's do it together. We said that when you have f of x, and when you compare that to f of negative x, if these are identical, you are dealing with an even function. Yeah. We also said that if you were to compare f of negative x with the opposite of the function, then that means you are dealing with an odd function. And if neither one of these scenarios take place, then the answer is neither. So therefore, for our problem right here, problem number 10, the answer is not neither. What's wrong with me with this neither crap? The answer is odd. There we go. And let's get fancy for Benita Applebum. Let's go ahead. You know what? We're gonna do this for Benita because let's move this out the way. Let's move this out the way because I have to show my work here with what's going on. Let's show this work as we get it all done here. And then we're going to paste this over here. We got that. We're going to put this right here. There we go. Boom. And we're going to move over from there. All right. So then, and so let's go ahead and move this over here. Yeah, we're going to do that. Look, bam, like that. I wanted to have the identical things working for me. And we're going to put the box in effect. Just like that. Done. Problem number 10. Problem number 10. Yeah. There we go. It's in a cube. There we go. So the answer is odd. There you go. And we cubed it. Done and done, ladies and gentlemen. Done and done. We're moving on to problem number 11. Where you at, Trig? Where you at, Trig people? Sandra says, amen. Benita Applebum says, I love it. I'm just trying to give you what you deserve. I'm just trying to give you what you deserve. Okay, let me love you with the math, man. Hook me up. We're looking at f of x. And f of x has a rational function. However, it has some trig in there. Oh, this looks scary. What are you going to do with this, Lewis? We have cosine of x divided by x squared plus 1. That's what we're looking at. That's what we have. Oh, it's a hot mess. Don't get confused. This is a hot mess. But let's see what happens. If we replace all the x's with negative x, guys, you'll have cosine of negative x. Okay? In the denominator, you'll have negative x squared. And then you have plus 1 there. Okay? Yeah, that's what's going on. And earlier in our notes, we confirmed that the cosine function itself was an even function, which meant that when you plug in negative x for x in a cosine function, you'll end up with the exact cosine of x. It's equivalent to that. That, in other words, cosine of negative x is equivalent to cosine of x. There you go. Not only that, in the denominator, negative x squared, that negative base raised to an even exponent, well, you're going to end up with a positive result. Negative times a negative is a positive all day long. You know that already. I mean, you didn't have to come to me to know that. I mean, you already knew. You already knew that was positive, right? So you end up with a positive x squared plus 1. And notice how this matches the original problem. Well, everybody's screaming it to me. Let me go ahead and show you guys what they're telling me. They're telling me, yeah. They're telling me that it's even. Lewis is telling me that the answer is even. Sandra is telling me that the answer is even. If we were to go a step further and look at the opposite of the original function, we would have ended up with the opposite of cosine of x divided by x squared plus 1. This doesn't match anything here. When you're making your comparisons, ladies and gentlemen, of the opposite of the function with f of negative x with the original function, the only thing that matches up is the original function and f of a negative x. Benita Applebaum is asking, is this trigonometry? The function cosine is trigonometry. The answer, Benita Applebaum, is yes. At the beginning of this video, I told you that I was going to give you some information that you could use in several courses, that you could use this in college algebra, that you could use this in pre-calculus, that you could use this in trigonometry, that you could use this in calculus courses. I'm giving you what you need right now to solve these types of problems in any of those courses. That's right. That is why I hope and wish that you guys can help me bring more knowledge to the world by sharing this stream right here, by liking the video, by continuing to comment, by continuing to support Fort Bend Tutoring, because I got more to give. Let me give it to you. That's right. That's right. Lewis says calculus is in the house. That's right. You can use these in all of the above. And all of the above. So what's the bottom line, guys? The bottom line is that this problem number 11, this answer is even. Let's go ahead and tell the world we are dealing with an even function. Ladies and gentlemen, there it is. There you go. Benita Applebaum says, oh, okay, I knew I haven't seen this before. This video gives me a leg up into my next course. Absolutely. And that's why we're here, Benita Applebaum, to help you in your future endeavors. There you go. We're putting value on the time that you're spending right now. You see what I'm saying? You getting a leg up. People over there, they twirling their thumbs. They're not even paying attention today. They don't even, you ask them what they're doing today. They're like, nothing. And what are you doing? Preparing for your future. Check that out, Benita Applebaum. I appreciate you guys hanging out with me. I really do. You're warming my heart over here. Got me having all warm and tingly feelings when I spend time with my people. I appreciate you guys. Let's look at problem number 12, guys. As promised, we have 12 problems, and guess what? We're on problem number 12. Let's go ahead and finish with a bang. All right? We can have problem number 12 here. We have our function. F of x equals to x cubed minus x divided by x squared plus 3. All right, I'm looking at you right now, Lewis. I'm expecting big things. All right, good stuff, Lydia. I'm expecting big things from you too. All right, so let's make sure that I get the correct answer. Let's make sure that you're getting the correct answer. Let's make sure that we are getting the correct answer for problem number 12 as we use the even and odd test in problem number 12, guys. Let's check it out. We're going to start by replacing all the x's with negative x. That's what you're going to do. Now, why does that equal sign look like it is? See, I'm just too excited. I got to calm down over here so I can get this problem right. So here, we're going to replace all the x's with negative x. So this is negative x cubed now minus negative x. Check out my parentheses around my terms, guys, because I'm guaranteeing that I'm doing it correctly. You must have that minus sign from the original numerator separate from your substitution of x with negative x. So make sure you're paying attention to how you plug in the negative x for all of the x's in the original function. In the denominator, you'll have negative x squared. That's supposed to be a 2 right there, which is ugly, which is why I'm going to fix it, because we're not going to leave us with an ugly 2 there. There we go. All right. And now we're going to simplify this problem. So when you plug in your negative x, you're going to simplify. Now we know with a negative base raised to an odd exponent, you're going to end up with a negative result, because a negative times a negative times a negative, it's negative. So this is just negative x cubed. Then the opposite of negative x is positive x. It is. I got my numerator simplified. What you doing? In the denominator, I have negative x squared. Well, that negative base raised to an even exponent was going to give me a positive result. A negative times a negative is a positive. So that's x squared. What? You heard me. Then I'm bringing down that positive 3. Right? Now, check this out, guys. If I were to factor out a negative in the numerator, right? If I were to factor out a negative in the numerator, I would have negative x cubed minus x all over x squared plus 3. Then this negative in the numerator could be brought out front to say that we have a negative x cubed minus x all over x squared plus 3. This confirms that this is the opposite of the original function. You see that? This confirms that this is the opposite of the original function. Now, what happens when we change the signs of the original function here? What happens when we change the signs of the original terms and we find out what the opposite of f of x is? Well, all you have to do is just put a negative in front of that original term there. I mean, that's all you got to do. I mean, this is the lazy part. You know what I'm saying? All you got to do is just put a negative in front. I mean, we love that part. Lydia says x cubed plus x divided by x squared plus 3. Oh, negative. That's right, Lydia. Don't forget. Do not forget, Lydia. Take your time. Now, this is what we're looking at, guys. Let me fix this. I want to fix it because it was blocking off some stuff. There we go. Let's fix that part. Here we go. Check this out, guys. Our f of negative x matches the opposite of the original function. What does this mean? When you have your substitution of x with negative x being equivalent to the opposite of f of x, doesn't that mean that we are dealing with an odd function? That's right, Sandra. The answer is odd. We're dealing with an odd function for problem number 12. I have a smile on my face. That's right, Bonita Applebum. That means that we're dealing with an odd function. Way to go, guys. That is awesome. You guys have been on fire today. Oh, this was an excellent stream. Are we not getting better as a community, guys? Are our live videos not getting better over time? I think they are. I think you guys are doing great. I'm doing good. We're doing good together. I'm excited for the future. I'm excited for the future. So what I'm going to do is I'm going to continue, if I can get my words together, I'm going to continue to get more content to share with you guys. You guys do your part, and you continue to support Fort Bend Tutoring by being here live with me to keep this thing going. And we're going to help the world with their mathematics. How about that? Together. What do you think? As a team. I think that's going to be wonderful, guys. I think that's going to be wonderful. So I want to remind you guys to subscribe to Fort Bend Tutoring. That's right. Make sure that you're clicking that bell icon so you can be notified when we go live with fresh and new content. Tell your friends, tell your family to subscribe to Fort Bend Tutoring. Tell the people that you hate to subscribe to Fort Bend Tutoring. Go ahead and help them out anyway. All right. And go ahead and tell your classmates and your teachers in your schools that Fort Bend Tutoring is here to assist them in their academic endeavors as well as for your individual academic endeavors. We are here to assist you, ladies and gentlemen. Thank you so much for sharing your time with me today, making sure that this video was on point. Lewis, you're on fire today. Sandra on fire. Bonita Applebaum on fire. All right. Lewis says that was an oddball. That last problem was an oddball. Lewis, thank you so much for your support, my man. That's right. Lovely Pookie is in the house. You take care. You take care. I appreciate all you guys. Much love to you. And as always, please like, comment, and rate the video. Ladies and gentlemen, share it. And if you haven't already, please donate, as that helps us bring you more free math tutorials from me, Mr. Witt, and Fort Bend Tutoring. Peace.
Thanks for watching. We appreciate you hanging out with Fort Bend Tutoring. Like the video, comment, and subscribe. Hit up our website, tutoringmath.net, and set up a private tutorial with me and FBT. Oh yeah, baby.